Hi everyone, what's up? Welcome back to my tutorial channel. Today we are going to work on some IFM practice problems, and we are going to focus on topic 10b, risk management using option. In this video I'm going to show you 9 problems. So let's look at the first problem. Question 1. You are given the following information about two options A and B on the same stock. Delta of A is 0.56 and of B is negative 0.41. Gamma of A is 0.07 and gamma of B is 0.09. You have just sold 500 units of B and you wish to delta gamma hedge your position. Which of the following is true? So basically for this problem we need to determine the number of units of option A and the number of shares of stock and whether we sell or buy, right? So there are two things we need to keep in mind when we solve this problem. First, if we sell, then the number of units should be negative, and if we buy, the number of units should be positive. And in order to delta gamma hedge your position, we need to make sure that delta and gamma of the portfolio are both 0. So here I'm gonna call, let's say I'm gonna call NS is the number of share of stocks, and NA is the number of option. Alright, so first, in order to usually we should start with gamma first because gamma of the stock is 0, so we can cancel out the stock term. Right, so let's start with gamma of the portfolio is 0. So we got gamma of the portfolio is 0, right? And this should be equal to, first, for option A, we got NA times with gamma A plus NB times gamma B. And remember, gamma of stock is 0, so we don't need to add it in here. So we got 0 here is equal to NA is not given, but gamma of A is 0.07, so we got 0.07 NA, and plus NB is negative 500 because we sold, right? We sold 500, so it should be, one second, it should be minus 500 times with gamma B, which is 0.09. See that? 0.09. So from here we got, what is NA? What should be NA? From here we got NA should be 500 times 0.09 over 0.07, and it should be equal to 642.86. So it should be 643, and it should be positive. So we have to buy 643 units of A, right? Units of A. Units of A. Now let's consider the stock one. Now, in order to find the number of shares of stocks, we have to use the second information. We want to delta hedge our position. That means delta of the portfolio is equal to 0, right? And delta of the portfolio here is NA, delta A plus NB, delta B plus NS. Delta S is 1, so we should have NS here. And now we got 0 is equal to NA is given, NA which is found out to be 643, right? So 643 times with gamma A is 0.56, right? Minus 500 times with delta B is 0.09. Oh, delta. Give me one second. There should be negative 0.41 here. Negative 0.41 plus NS, right? So solve this equation for NS. We got NS should be, let's see, it should be minus see, it should be negative. Okay, 500 times 0.41 plus 643 times 0.56, we got 565, and it should be negative 565. So yeah, 565. So that means we sell 565 share of stocks, right? Shares of stocks. See that? So in this problem, we have to buy 643 units of A and sell 565 shares of stocks, right? So the correct answer here is buy 64 and sell 565. So it should be D. It should be D. Why is it not working right now? Yeah, it should be D. Alright, so that is question 1. Now let's look at question 2. Assume the Black-Scholes framework, you purchase a European call option on 100 shares of stock expiring in 90 days. The option price is 278.04. The current price of the stock and the strike price of the option are both 40 per share. Delta of the call is 0.5824 at time purchase. Which of the following is or true of delta hedging strategy? You can delta hedge by selling 58.24 shares of stock short. There is no cash generated or used when this hedge is set up, and delta hedging guarantees zero loss if there is a decrease in the stock price later. Alright, so let's justify them one by one. Here you can delta hedge by selling 58.24 shares of stock short. This is correct because the delta of call is 0.5824, and we got a number of units of the share is 100. So we basically, in order to balance delta of the portfolio, we can just short sell in 58.24 shares of stock short. That's correct. That is correct. Now there's no cash generated or used when this head is set up. Well, if this head is set up, then we have to short sell in 58.24 shares of stock short. So basically we will get back 58.24 times with the price of the stock, which is $40 per share. And don't forget to time with 100 units. So we pay 278, and now we after we sell, we get 5824 times 40. We got let's say 2960. Of course, there is a cash generated, so this is false, right? And delta hedging guarantee zero loss if there is a decrease in stock price later. Here we notice that delta is positive, so if there is a decrease in the stock price, then there should be a big loss. So it doesn't guarantee zero loss. It should be false, right? It should be false. So the only statement is correct should be you can only delta hedge by selling 58.24 shares of stock short. That is the answer. Alright, question 3 is, this question is similar to the first question. You are given the following information about two options A and B on the same stock, A, B, delta, gamma. You have just purchased 1,000 units of stock of option A, and you wish to delta gamma hedge your position. Which of the following is true? The same thing with the first problem, right? So let's look at gamma first, right? Let's look at gamma first. We got gamma of the portfolio. Gamma of the portfolio is equal to NAs times gamma A, and A is 1,000. And we butcher, so 1,000 here is positive, right? Gamma A plus B is NB, right? NB times what gamma B is 0.09. And gamma A is given, right? Gamma A is given, which is 0.07. Let's say 0.07. So from here we can find the number of option B is, let's see, as 1,000 times with 0.07 divided by negative 0.09. It should be negative 778, which means that none of the above is correct, because there's no option mentioned B in here, so none of the above is correct, because we need to sell 770A B, and we can continue to work on the number of stocks. But here there's no option mentioned in B, so none of the above is correct. Alright, next. Assume the Black-Scholes framework for a non-dividend paying stock. You are given the current stock price 20, the delta and gamma of 22 tri-European put option expiring in 1 year are negative 0.55 and 0.066 respectively. You have just purchased 1,000 units of 22 tri-European call option expiring in 1 year. Determine the number of stocks you need to buy or sell to delta hedge your position. The current stock price is 20. Alright, so here we have purchased 22 tri-European call option, but they give us the delta of the put option and the gamma of the put option. And here we just have to delta hedge our position, so we don't need to care about gamma. So we can just cross gamma. We don't need gamma. And here we're given delta of put option, but the question asking about call option, so you have to find delta of call option before we hedge the position. So remember, for put option, delta put is equal to minus phi of minus D1, right? But delta of call is phi of D1, right? Phi of D1. You have delta of call is phi of D1, right? That's phi of D1. So from delta of put option, it is possible to find out delta of call, right? Delta of put is negative 0.55, right? So we got negative 0.55 here is minus phi of minus D1, leading to phi of minus D1 is 0.55, right? So from here we got phi of minus D1 is 0.55. So phi of D1 here should be 1 minus phi of minus D1, which is 0.45, right? 0.45. So now if we want to delta hedge the position, let me do it here. Delta is equal to 0, right? Delta of the portfolio, and delta of the portfolio is 1,000. We purchase the call options are 1,000 is positive. Time what delta of call option is 0.45, right? 0.45 plus NS. Time what delta of NS is 1. Time with 1, right? So leading to, we got NS here should be negative 550, right? So NS is negative 550. That means we have to sell 550 share of stocks, right? We have to sell. So the answer here, let me change the color. So we sell 550 share of stocks, right? Share stocks. You see that? So the answer is sell 550 share of stocks. You understand what I'm saying? Alright. So the answer is sell. Oh, my Apple Pen is not working. Alright, next problem. Which of the following are true about mortgage guarantee insurance? 1. The benefit makes monthly mortgage payment to the lender if the borrower is unable to make them. Let me zoom it up a little bit so you can see it better. The benefits make monthly mortgage payment to the lender if the borrower is unable to make them. This is completely wrong. Let's say if you buy a house, the insurance company not gonna pay for your house in case you cannot pay them. They're just gonna help you to sell the house and then use that to subtract the mortgage in the bank. But they don't help you. They don't help you to pay for the mortgage. So the first one is wrong. See that? Second one, it is effectively an option where the borrower can cancel the loan for the net value of the mortgage home. That is not correct either. They cannot cancel the loan. They have to sell the house and use the house to put it back there and see whether they pay enough, or and just compare if they have to pay for the gap if there is a gap, or they can have money if the value of the house is more than the loan they have in the bank. So it's completely wrong. Mortgage guarantee insurance only covers the amount of the loan. It does not cover costs associated with foreclosure. This is not correct either. So R is wrong. R is wrong. Next, which of the following are true of an enhanced income death benefit guarantee defined as 25% of the account value in excess of the initial investment amount will be added if the account value at death is greater than the initial investment? Let K be the original amount invested, and let ST be the amount value at time t, and let tx be the future time of debt of the contract holder. The amount of the enhanced debt benefit is B is this. Is it correct or not correct? This is incorrect, because if you read the statement again, you say 25% of the account value in excess of the initial investment will be added. So that means we should have 25% of the assets. That means FT minus K. So it should be 25% of the gap between the stock price and K, not 25% of the stock price. Alright, so the first one is false. You see that? This is false. The second statement, the enhanced income debt benefit is intended to approximate actual income taxes when the debt benefits assess the cost of contract. That is correct. So that is true. An annuity can have an enhanced income debt benefit or a minimum guaranteed debt benefit, but not both. This is incorrect. We can have both. We will be able to have both, so it should be false. This one probably have to read the context about enhanced income debt benefit. So the only statement correct is 2. Alright, question 7. Assume the Black-Scholes framework, a market maker who delta hedges sells a assessment at the money European call option on a non-dividend paying stock. So this means sigma is equal to 0. You are given the current stock price is 40. This is S0. Right, this is S0. The volatility is sigma less than 30%. The continuous compound free interest rate R is 5%. The call option delta, we got delta call is 0.5910, and there are 365 days in the year. If after 1 day the stock price has gone up and the market maker has 0 profits of loss, determine the stock price move over the day. So for this problem, basically in order to find the stock price and the stock price move over the day, after 1 day, we have to find, it should be S0 times with sigma's square root of h, and h here is the length of time, and it should be 1 over 365. So in order to find this amount, we need to first determine sigma, because S0 is given at 40 and h here is just 1 over 365. Sigma is not given. In order to find sigma, we have to use the information of the delta. So we got here, what is delta? Delta is phi of d1, right, phi of d1 times with e to the minus delta t, but delta is equal to 0, so it's just phi of d1. And u d1 to find sigma, right? So we got what? We got 0.5910 is phi of d1. Right, from here, use the table, we will be able to find d1. Right, we will be able to find d1. So let me switch to d1. Switch to the 0.5. I'm gonna use the z table to find d1. Right, 0.5910, 0.5910. So I'm gonna go to the z table right here. 0.5910. It should be at the positive table. 0.5910, right? 5910. So 0.5910, 5910 is right here. It's right here. It's right here. See that? So the z-score should be 0.22 or 23, right? 0.23. All right, now we go back there. So d1 is 0.23, right? d1 is 0.23. So here we got d1. We got d1 is 0.23, right? 0.23. So we got d1. I'm gonna write here 0.23. And now I'm gonna erase the bar. Okay, I'm gonna erase the bar because I need more space for it. I'm gonna erase the board. I'm gonna erase the board. So we got what? We got 0.23 is equal to natural log of S0 over k. Is k here given? Here's an k not given, so we assume this is just the same with the initial price, so it should be 40 over 40. Right, 40 over 40. Plus R is 0.05. Delta is equal to 0 minus sigma square, which is sigma square over 2 over sigma square root of t. T here is 1 year, so it's just 1. So it's just sigma. And from here, we are going to solve for sigma. Right, we are going to solve for sigma. This is just 0. So from here, let's solve for sigma. It should be a quadratic equation, right? Quadratic equation. Let me write down the equation and we continue. We got 0.05 minus sigma square half is equal to 20.23 sigma. So 0.1 minus sigma square is equal to 0.46 sigma. So sigma square minus 0.46 sigma, plus minus 0.1 is equal to 0. Alright, so I'm going to have a quadratic equation that is sigma square, sigma square sigma square plus 0.46 sigma minus 0.1 is equal to 0. And from here we solve for sigma. Erase the board. So sigma here is what? Just use the quadratic formula. Either negative 0.85, but of course this is not the correct answer, or .60. Let's see. 0.46 sigma. It should be 0.15, and it's less than 30%. So this is sigma, right? So sigma is, I'm gonna change color. So I got sigma is 0.16, right? 0.16. Now I'm gonna erase the board again. So we got sigma, and now we need to find the new price. So we got S0 times sigma times square root of h. It should be equal to 40 times 0.16 times square root of 1 over 365, and it should be equal to 0.33. So this is the stock price move over the day. Alright, so next problem. Question 8. Which of the following are which of the following are false statements about a variable annuity with a guaranteed minimum death benefit, GMDB, The annuity account value can be represented by a share of stock. At death of the owner, it pays greater of the stock value or the initial investment accumulated at a guaranteed rate of interest. This is false because by the GMDB, the guaranteed minimum debt policy benefit, we do not have rate of interest. They should pay the greater of the stock value and the initial investment, but there's no interest associated. So the first one is false. Then the second statement, the value of the GMDB, the guaranteed minimum debt benefit, is the value of a European put option for the initial investment expiring on the expected day of the debt. There's no way to know the expected day of the debt, so that is false. So there's no way we can know when the person die, right? At the status maturity day, returns the greater of the stock value or the initial investment accumulated at the guaranteed rate of interest. It's none of these because there's no interest that guaranteed. We don't have interest in this problem. Alright, question 10. A policyholder owns a variable annuity contract with a death benefits feature defined as follows. GMDB will return of single premium the greater of the account value, and the initial investment of $5,000 will be paid when the policyholder dies. Enhanced income death benefit guarantee 35% of the account value in excess of the initial investment amount will be added if the account value is greater than the initial investment when the policyholder dies. At time 4, the policyholder died and the account value at the time was $5,500. Determine the total benefit paid to the policyholder. So here at time 4, the policyholder died, so it died. When it died, the GMDB pay the greater of the account value and the initial investment, but here the value is $5,500 and the initial investment is $5,000. So basically we got $5,500 paid, and the enhanced income death benefit guarantee 35% in the excess. The excess here is $5,500 minus 5,000, right? Minus 5,000, which is 500, and we get 35% of the excess. So we got 0.35 times with 500, and we got 5,675. So this is the enhanced income death benefit guarantee and the guarantee minimum death benefit together. So this is the total benefit back to the policyholder. Alright, so that's it for today. Thanks so much for watching. I hope you guys enjoyed my lesson, and see you on the next video. Bye bye.